All right, let's look at another rate of change problem. In this case, we're given a function for a person's blood alcohol content over time, but we're given it as a graph and not as a table or like in the last problem, it was given as a formula. We're just given the function as a graph. And so what we want to do is estimate the average rate of change of the blood alcohol content over time, over these different time intervals. All right, so now you have to read the graph. So that can be a little bit tricky. So I'm going to first take a look at, it looks like we want to find the average rate of change between 2 and 4, between 2 and 3, between 2 and 2.5, and then again between 2 and 2.25. So we're the left-hand side of the time interval is always 2, and then we're taking values that are closer and closer to 2 on the right-hand side. So the first thing I've done is just try to use the graph to estimate the blood alcohol content at those various time values. All right, so I've marked them off on the graph. I don't know how well you can see them, but I need those in order to calculate the average rate of change over each of these time periods. Okay, so to get the average rate of change from t equals 2 to t equals 4, I'm just going to take the difference in the blood alcohol content. So I'm going to take the 0.02 minus 0.045 and then divide it by 2, which is the time interval, right? 4 minus 2. And so what I got here was a negative 0.0125. Okay, so that's my estimate of the average rate of change over that time interval. So I'm just going to do that for each of these time intervals. All right, so I've calculated those rates of change, and you can see that as those time values get closer and closer together, it looks kind of like, based on this, what as well as I can estimate from the graph, it looks like it's approaching about a negative 0.016. So what is my best estimate for the rate of change of the blood alcohol content at time t equals 2? I would estimate it to be negative 0.016. Okay, that would be at 2 hours after you stop drinking. All right, now I don't know about the units on this thing. It doesn't really say. Oh, I guess it's okay. Get this is in grams per 100 milliliters of blood. Okay, so this would be in grams per 100 milliliters of blood, right? That's what the blood alcohol content is measured in. But because this is, the average rate of change over time, this would be per hour because our T is in hours. All right. So now what we've done an instantaneous rate of change. All right. A general instantaneous rate of change. Okay, we took average rate of change, before we had average velocity, and we calculated instantaneous velocity. Now we've taken an average rate of change, and when we look at it at a particular time, we try to estimate it at a particular time and not over a time interval. That's instantaneous rate of change. All right, so the instantaneous rate of change of a function at some value is defined to be the limit of the average rate of change over of the function over shorter and shorter time intervals around that point A, right? In this case, our A is 2, right? So we're trying to find the instantaneous rate of change of the blood alcohol content at t equals 2, and we're taking time intervals that are shorter and shorter around t equals 2. Okay, to estimate the instantaneous rate of change. And instantaneous rate of change is the basis of the derivative in calculus. Okay, so this is showing us kind of what we did in general. We can visualize the instantaneous rate of change of a function as the slope of the line between 2 points, and as we move those 2 points closer and closer together, we get the slope at an instant, right? We get an instantaneous rate of change. Okay. So the derivative of a function at a point is defined to be the instantaneous rate of change of that function at that point. So the derivative is the instantaneous rate of change. All right, it's the slope at that point. We can think of it as the slope of that point, or the slope of a tangent line at that point. Okay. Now remember when we looked at average rate of change, we were looking at the slope of a secant line. We call it a secant line if it passes through 2 points. So if we're looking at the average rate of change, we're looking at the slope of a secant line. And as those points get closer and closer together, the line touches at 1 point instead of 2 points, and we call that a tangent line, where it just kisses the graph. Okay, and so the derivative of a function is the slope of the graph at that point, or is the slope of a tangent line at that point. All right, and if that function is increasing, right, the slope is going to be positive, and so the derivative is positive. And if the function is decreasing, then the slope would be negative. Like in the case of the blood alcohol content, we had a negative instantaneous rate of change, and so if the function is decreasing, then the derivative is negative. All right. So I'll meet you in the next video.